Hello. Well, here we are. So let's look into problems with semaphores. There's in basically there's some things that you should be aware of, and most people get it wrong when they're using semaphores. Particularly, they're using signal wrongly, or they're using weight function wrongly, mm, or they forgot to put in the weight or signal function within their code. And these are some of the other examples of what can occur when semaphores and other synchronization tools are used incorrectly, right? So, um, one of the idea of making it easier is to have a monitors, right? Uh, and a monitor is basically a high-level abstraction that provides a convenient and effective mechanism for processes to basically synchronize, right? Within this monitor, there's some kind of abstract data type, internal variables, which is only accessible by code within the procedures themselves, and only one process may achieve within the monitor at any given time, right? So a basic idea of what how a monitor would look like is, when we abstract it, a monitor would have certain procedures within it: procedure process 1, procedure process 2, and procedure process 3, for example, and some initialization code that would run on it. So it's kind of provides some kind of abstraction for it. And if we look into it, basically it's how how each process would be within a monitor. They have some kind of shared data, and processes will be put into a queue, and where they are allowed to run, and and depending on where they are in the queue, exit the queue to execute certain kind of instructions, right? So this is particularly one of the ideas being used, right? So the next thing that we will look for, like, how do we implement a monitor basically using semaphores, right? So some of the variables that basically we need, basically a semaphore itself, we call it mutex, and in this example we use mutex equals to 1, right? Each procedure themselves is replaced by some kind of body of p, or function of p, right? So we have each of them would wait, and then will be signal, right? So when wait is being called, they would basically run or sit in the queue, and then they would be able to run after they will receive a signal from either anybody within the monitor, right? So if they are right in front of the queue, they may be able to run, and if they're not, then they would have to wait in the queue. So mutual exclusion within a monitor in this case is basically ensured, right? So there's, of course, we need some condition variables. There's two operations that are allowed on a condition variable: either x.wait, a process that invokes the operation, is suspended until it receives a signal, as x.signal, right, where they resumes one process after, if any, that wait was called, right? So if there's no x.wait on the variable, then it has no effect on the variable itself, right? Okay, so if we continue on and look at this, so basically q are associated with x and y conditions, and they would basically enter the queue this way, right? And they would sit within a queue for each process that are running, right? Okay, so the usage of condition variables is such as this, right? So we consider that we have two processes here, P1 and P2. This is just example that needs to execute two statements, either S1 and S2, and the requirement that S1 to happen before S2 happen. So, and this idea is that we have there's two processes, that needs to execute two statements, right? S1 or S2. And S2 needs to run first before S1 gets to run, right? So in order to do this, we create a monitor with two procedures, right? F1 and F2, function 1 and function 2, that are invoked by P1 and P2 respectively, right? So one condition variable X is basically initialized in this case, and one Boolean variable done, right? So this X and a variable done, right? A Boolean variable. So in F1, if we have statement 1, function 2, right? When it's done, then X dot signal, right? So basically it's telling that it is done, and it's telling other people that, I'm done, and other people can start doing what they want to do, right? So if done equals to false, then then other people can call a wait to see whether they are allowed to run, and if the block is not blocked, then they are able to run somehow, right? Okay, so this is the basic idea of getting it to be able to run in this case, right? So the monitor implementation would then look very similar to, we have a mutex, we have a next, and an integer next count, number of processes waiting inside the monitor. So inside the monitor, there's two functions that the processes that wants to run basically, and inside that processes, there's two functions that want to run. So two processes, two functions, right? S1 and S2, as we talk about, right? So each function P will be replaced by some kind of await mutex and a body of P, and we have a semaphore, two semaphores here. One is for the next, one is for mutex. So, and we keep track of the count. So if the next count is bigger than 0, signal the next one, else signal mutex, right? So it gets pretty confusing, but this the things that we do on the monitor helps multiple processes and multiple functions that we want to execute, that can ensure mutual exclusion is ensured in such a way, right? Now for each condition variable X, we would also define the operation of it, right? And we also count the number of X's running, and etc., right? So it's good to know the gist of the problem here, that a monitor basically abstract the idea of mutual exclusion, and the coding for it can be simplified to this abstraction layer, right? So we're going to come back to look into how processes are resumed in this case, and in the next series of the video recording, right? See you soon.